Alright, in the previous video we have explained how to insert a new node into a linked list. We have learned that there are three ways of inserting a node to a linked list, which are inserting a node in the beginning of linked list, inserting a node at the end of linked list, and finally inserting a node after a particular node. So in this video we will combine all these three types of insertion in one algorithm to make it easier for us when we create it using any programming language. Here in this picture you see our algorithm for insertion in linked list. So the algorithm starts from over here. We start creating a method which takes two parameters over here. The first parameter is node value and the second parameter is location. Node value is the value of node that we want to insert into this single linked list, and the location is where we want to insert this newly created node in our single linked list. So the first step in our method, we are creating a new node and assigning a value to this node, and this value comes from the parameter from the methods parameter over here. Then we are continuing to the next step. In the next step we are checking that if head is equal to null or not. This means that if head is null, this means that we don't have any node in our single linked list, so we are adding our first node to this single linked list by referencing head and tail to this node. But if our head is not null, then we are continuing to the step over here, in which we will check location parameter. This location parameter comes from here. So if we are inserting a node at the beginning of linked list, we will continue over here, in which we are updating the next reference of newly created node to head and head to node. What does it mean? We know that the next reference of the node that we created is empty now. So we assign the value of head to it, which is a physical location of node 1 in our single linked list. By doing this, we create a link between a new node that we created and the first node, because we know that the value in the head is reference to the first node. So then we have to create a reference between a head and newly created node. So assigning the location of newly created node to head, we are creating a link between head and newly created node. And the previously created link between head and node 1 gets deleted. By doing this, we successfully insert newly created node at the beginning of single linked list. Let's see how this is working in a real example. Here we have a sample single linked list like this, and we want to insert this node over here at the beginning of this list over here. So I took the part from the algorithm which is implementing this process. So here the first thing that we are doing is we are setting these nodes next reference to head. So now this node's next reference is empty. So by setting this next reference to head, we are updating the next reference of this node over here to 001. And this is creating a link between this node over here and the first node over here, because 001 is the physical location of first node over here. Then we are setting head to this node, which means that we are taking the physical location of this node over here and updating to head. And this is creating a link between this newly created node over here and head. And by creating this link over here, we are deleting the link between head and first node over here. Now the first node becomes this newly created node over here. So this part of algorithm is responsible for adding a new node at the beginning of single linked list. Now let's continue to the next step in our algorithm. Here the next step is, once again we are checking the location parameter. Here we check that if the location parameter is not equal to first, then we continue to the next step. Here we are checking if the location parameter is equal to last, then this part of algorithm will be processed. Here we are inserting a node at the end of linked list. We know that we have created a node over here and assigned a value to it, and the reference of this node is null. To insert newly created node at the end of linked list, we need to set its next reference to null, because we know that in single linked list the last node's next reference is null. So the first step that we are doing over here, we are setting the next reference of this newly created node to null. The next thing that we are going to do, we need to update last node's next reference to this node. So we are setting over here the last node's next reference to node. Then we need to create a connection between tail and node. So here we are setting tail reference to node. And with this newly created node is added at the end of linked list. Now let's see how this part of algorithm works in real life example. Here one more time we have single linked list like this. We have a newly created node here. So we want to add this newly created node at the end of this single linked list over here. So as we said, the first thing that we are going to do, we will set the next reference of this node over here to null. Then the next step is we need to set last node's next reference to this node. So we need to update last node's next reference to this node's physical location. And this will create a link between last node and this newly created node. Then we need to create a reference between tail and this newly created node. So we need to update tail with this newly created node. So this will create a link between tail and newly created node. And by creating a link between this node and tail, we are deleting the link between tail and the last node that we had before. And this is how it works, this part of algorithm in the real life example. Now let's continue to the next step in our algorithm. The next step is if the location is not equal to last, then we continue over here, which means that we need to add a newly created node in the middle of single linked list. So here we need to find in which location we are going to insert a newly created node. To find it, we need to loop through all elements of single linked list. Then after finding the current node, we will set the current node reference to this newly created node and this newly created node's reference to the next node in the linked list. So let's see how this is working in real life example. So here again we have sample single linked list like this. So we want to insert this newly created node after this node over here. So the first step in our algorithm, we need to find a location. So we will start loop from the first node until we find the location that we want to insert. So in this case, as we said, we want to insert a new node after this node over here. So our current node is 4. So the next step in our algorithm, we need to send current node's next node to this node. So we will update current node's reference over here to 444, which is physical location of newly created node over here. So by updating this physical location to here, we are creating a connection between this node and this node over here. So we are creating a connection between node 6 and node 4 over here. Then the next step in our algorithm is we need to set the next reference of this node over here to the next node. So our next node is 5 over here and the physical location of this node is 33. So we need to update this 333 to this node's reference. So by updating it, we are creating a connection between these two nodes. And when we create a connection between these two nodes, previously created connection over here is automatically get deleted. So by this, we are inserting an element in the middle of single linked list. Okay, now we have an idea of how the insertion algorithm works in 3 different situations. Now in the next lecture, let's use this algorithm to create a method for inserting a node to the given linked list and see what is the time and space complexity for this insertion in single linked list. See you over there.